This is Advent of Code 2020, day 14. This is the first part of the problem for docking data. So we're still on the ferry, headed towards this small island on which we're going to take some buses from the previous day's problem. And we need to help out in decoding some values from a chip, I guess. So this computer system stores things with a strange bitmask system. And so we're going to be applying a bunch of values to the memory of the system using that bitmask. And then we ultimately want to see what values are left in memory, sum them all up, and that's the answer to our puzzle. So the way that this strange bitmask system works is that we've got a series of X's and 1's and 0's as any given mask. So anywhere where there's an X, as we apply that bitmask to a value, we just preserve the value that's there. So we've got a binary representation here. So X applied to 1 is just going to leave 1. X applied to 0 is going to leave 0. Where the mask gets interesting is if we have a 0 value instead of an X, then regardless of what the value at that position in the binary string is, we want 0. And similarly with 1, regardless of what the value is in the binary string, we want 1. So 1's and 0's come through as 1's and 0's. All of the X's remain as they are. Now we could parse out some data from the mask and look at these binary values and sort of do a bunch of string manipulation to work towards a solution. But I think there's some bitwise binary operation logic that we can apply to these instead. So for starters, let's just to get a sense of how this example is working. If I take the mask here, and we can open up a pry session, and I will say that this is my mask. And then I will grab this value, or perhaps I'll grab this value because part of the problem will be producing some binary from a given decimal value. So we'll take the 11 and we'll say toString2, and that gives us some 1011, which matches 1011. So in order to apply this mask to this value, we're going to want a way of combining this mask with the value to translate the 0's into 0's, and then a way of combining this so that the 1's get translated into 1's. So I think we're going to have to treat this mask in two parts. So we'll say mask 1 gets the mask, and we'll substitute all versions of X for 0. Oops, this got to be a string as well. And so what we end up revealing is we have a string full of 0's, and then the 1's are what then pop out as sort of distinct in this mask then. And so if we were to take that or if we were to take mask 1, and if we were to first turn that into an integer, and if we were to OR that with our 11, and if we turned the whole thing back into a binary string, we can see that we preserve everything about the 11, the 1001, and it's this 1 value that gets translated in. And so that's how we can bring the 1 over, is by ORing the mask with doing a bitwise OR of our mask with our value. And then if we take that value and we and it with mask 2. So mask 2 will be a mask where we g-sub all of the x's for 1s. So the thing that pops out here is this 0. And so this, if we AND it with the number, it's going to preserve all of the unique values that lines up, all the values that lines up with the 1s, and then it's this 0 value that's going to get pushed through as a 0. So I will take this now and we will AND it with mask 2, and we will turn this back into a binary string. Oops, and I missed something. Oh, gotta turn this into a binary integer, or binary numerical value. And there we go. We get our 1 coming through, we get our 0 coming through, and the rest of the bits of the 11 are preserved. So this is the formula for applying our mask. So if we X out of here, I think we can start working on part 1. So mask is going to get something set to some value that we parse out of our input file. Mask 1 is going to be the mask g-subbing all x's with 0s. Mask 2 is going to be the mask where we sub x's for 1s. And then apply bit mask is going to I guess take a value, mask 1 and a mask 2, and then it's going to be this thing. So let's say that's our value. All right. The one thing I'm thinking about now is I wonder if the ordering of the value in the mask 1 matter. Yeah, I think it may. Let's see. So if we have some binary, let's say this is our mask. If we OR that with the thing where we want to preserve all values and then turn 1s into 1s, yeah, that's fine. That's fine. Okay, so that will work. Wonderful. So I think from there we have, I guess, the task of reading in some input. So let's jump over here and get our puzzle input. Command A, Command C to copy it. And we will create an input.txt file and paste it in. And so we can see with the input, we have a mask set. We stick some values in memory using that mask. Then the mask changes. We stick more values into memory with this new mask. So we're going to have to process it line by line, I suppose. So we've got mask and memory. I'm just going to copy these first two lines just so I have a point of reference. We'll say file gets file.read .txt. And then I guess we're going to have instructions. So those are going to be splitting on new lines for this incoming file. And that'll be each of our instructions. And so then for each instruction, oops, we'll have to identify whether it's setting the mask or setting some memory value. And speaking of memory values, we're going to want to keep track of a bunch of values in memory. I'll use a hash because I'm thinking we can just set arbitrary integer keys, and then if we ever have the same integer come up more than once, then it'll be trivial to replace it in a hash because of the keys. Paste. And so let's see if I guess if instruction.match so a new line, then mask equals, and then a bunch of, I'll do a capture group that just contains a bunch of stuff, and then we'll close the capture group, and then it's the end of the file. So if we match on that, and that's not nil, so if mask match, then say mask match captures first is our is our mask. Else, and otherwise we're processing the a memory line. So we'll have a instruction.match, and so we'll match in the beginning of the line, then we'll look for mem, open bracket, then we'll look for some number of digits, and then we'll close our capture, close that bracket, we'll have an equal, and then we'll have another capture group where we have some number of digits. We'll close that, and we're at the end. So this will be a mem match. And from there, I guess we'll probably apply bit mask and then update memory with value. So mem match will give us the memory location and the I guess just value that we're gonna have to mask. So we'll get that from mem match captures, just destructure that out. So I like the looks of where this is headed, but I would like to pry in here so I can double check that I've got these regexes right. So I'm gonna run part 1 so far. And actually, let's see if I jump back over here, grab this line, and we can say, does this match here? Awesome, it does. And I believe if we were to apply the, something that didn't match like this, we just get nil, which I think it'll break out of this if statement. Yeah. Okay, and as for this line, did we get this right? This match, and that gets nil. So I wonder if we maybe need to do something special with these brackets. Maybe these need to be escaped. Okay, they do. So yeah, those brackets are special characters, hence them needing to be escaped. And now I think we can feel good about these regular expressions. We can call apply bit mask with our value, our compute these mask values here. Although I suppose we don't need to do these each time. We can say mask 1, mask 2, and then we'll update them in here when they come up, every time the mask changes. Otherwise we can just reuse mask 1 and mask 2. Great, I think that'll work. So this is going to return, I guess, a string, and you actually just want it to return the integer, because the integer is then what we will put into the memory slot. So we'll say memory location gets mask value. So we'll just iterate over all the instructions to do this, and then at the very end, we will, I guess, take memory.values.sum, and we'll print that out. And before we run it on the big input, let's make sure it's working on the smaller input. So I'll say sample.txt, and then I will grab this right here, paste that in, oops, mask, there we go. Part1, and so I'll say sample.txt, and let's run part1 and see what happened. String can't be coerced into integer. So on line 13, oh sure, values coming in as a is being extracted from the string as a string itself. So we need to call to on this before we pass it in there. We get 165, and is that gonna line up? Yeah, 165. Cool. So let's run it on the full input now and see if we've got an answer. That's quite a number. But does it give us a star? Oh, it does. All right. Well, that's part one. We'll see you in the next video for part 2. Thanks for watching.